In this video, I'd like to talk about the zeros of polynomials when they're written in factored form. And remember the zeros, we have several words for these. These are the roots of the polynomials, but in practice, these are just the x-intercepts. So when we graph the polynomial, the zeros are essentially wherever it goes through this x-axis, depending on what the shape of the polynomial is. And in this problem, and in all of these problems, we're going to be given a polynomial in factored form, and we want to be able to find these x-intercepts. And factored form is usually the easiest way to find the x-intercepts, since we can use what is called our zero product property, where basically if two numbers are multiplied together, or several numbers, if one of these is zero, like let's say b equals 0, then it doesn't matter what a is. A could be anything, since 0 times anything would be 0. So we'll essentially look at each of these factored binomials, or in this case a monomial, and figure out when that itself would be equal to 0. For instance, if x is 1 here, you'd have 1 minus 1, which is 0, and 0 times whatever these other expressions evaluate to would still be 0, since 0 times anything is equal to 0. And for this problem, we want the polynomial to be in this factored form. But if you want to get a better idea of what this polynomial looks like in standard form, we would have to multiply everything out. And it's a bit tedious, but basically you distribute the x into this first one, then you would multiply this product from the x and these two terms by this expression. You would get some type of other polynomial, which you could then multiply by this binomial. And it takes a while, but you can multiply everything out. And when you do that, you would end up with some fourth degree polynomial. And the reason that I know that is the highest power term always comes from multiplying all of the highest power terms in each of these individual expressions. So x times 2x times x times x, and you would end up with 2x to the fourth. Now the other terms take a little bit more work to get, but they would be there as well. So this is some fourth degree polynomial where the leading coefficient is 2. But again, this doesn't really matter yet. What we're trying to do now is just figure out the x-intercepts. And eventually, knowing what type of polynomial it is and what the leading coefficient is can help us determine essentially a rough picture of the rest of the graph and what's known as the end behavior of the polynomial. But that will come in later videos. So for now, we just want to find these zeros. And like I mentioned, we're going to use this zero product property. So to use this property here, we're going to look at each of these expressions. 3 of them are binomials, 2-term expressions, and this one in front is a 1-term expression. And we want to think, when do each of these equal 0? And some of them you'll find are fairly quick. Like for instance, this first one out here, if you just plug in 0 there, then you'd have 0 times whatever these are, but it doesn't matter since 0 times anything is 0. So 0 is one of the roots, or one of the zeros of this polynomial, which we'd be able to graph here. And notice this problem says the interactive graph, so if you use the Khan Academy, you'll be able to just click these points in. But for us, or for this video, I'll just draw them in. Now, a lot of the other ones can be simple as well, since you can visually see that if you plug in 1 here, 1 minus 1 is 0. And likewise, if you ask which x value makes this 0, it would be -2. So 1 and -2 are also the zeros of this polynomial. But this expression here, this 2x plus 3, that might be harder to guess. So what we can do is set it equal to 0, since we're trying to find that particular x value that makes this 0. And we can just solve for that. So if we subtract 3 on each side, we would get 2x is -3, and then divide everything by 2. Let me just make a little bit more room. So we'd get that x is -3/2. Let me rewrite that. And so I can add that, this -3/2, to this list here. And from here, we want to just plot these points. So it goes through at 0, at 1, at -2, but also minus 3 over 2, which is the same as minus 1.5. So that would be right there. And this would finish the problem. But in a later video, since we know the highest power of x and we know its leading coefficient, this will essentially behave like the parent function y equals x to the fourth when you look at really big values of x or really negative values of x. So what we'll learn in a later video is that the function will come down, it'll pass through, and then go back up, and just kind of snake its way through these points. But there's a lot more we'll need to know before we can do that with any kind of accuracy. So for now, we're just going to plot these points and leave it as is.